Hello. In this presentation, I'm going to introduce a new product, but made by Saturn PCB, called the NITRO. If you think this product looks familiar, it is exactly the same size, shape, and form factor as an Arduino Nano board. It has the same power requirements as an Arduino Nano. You can either bring in voltage through the V-in pin between 7 and 15 volts. You can bring in a USB connection which supplies 5 volts, which is then used to generate the 3.3 volts. Or you can power it through the 5-volt input, but that's where the similarities pretty much end. The NITRO contains many more modules, has a much bigger CPU, a lot more RAM, flash, and EEPROM. The Nano is an 8-bit microprocessor that runs up to 16 megahertz. The NITRO is a 32-bit processor with a 64-bit accumulator that runs up to 120 megahertz. The Nano has 2K of SRAM, while the NITRO has 256K of SRAM. The Nano has 32K of flash, the NITRO has 1 megabyte of flash. The Nano has 1 kilobit EEPROM, NITRO has 4 kbytes of EEPROM. The Nano has a 10-bit A to D converter, which can read 6 channels. The NITRO has 7 A to D modules, each of them 12 bits, and 20 analog inputs that can be channeled into those 7 analog converters. The Nano has 2 8-bit timers. The NITRO has 9 timers. They can be either 16 or 32-bit. The Nano runs at 1 MIPS per megahertz, so at 16 megahertz, it's running at 16 MIPS. The NITRO can run up to 198 DMIPS, which is dry stone MIPS. The NITRO has a lot of other modules that are built in. It has a watchdog timer, a deadman timer. It has RC oscillators that run at 32 kilohertz. The NITRO also has up to 12 PWM pairs with both leading edge and trailing edge blanking. They each have dead time for rising and falling edges and dead time compensation. And the PWMs have a resolution of 8.33 nanoseconds. There's 6 quadrature encoder interface modules, each having 4 inputs, phase A, phase B, home, and index. It can handle external graphics interfaces through PMP. It has up to 6 I2S audio data communication interfaces, up to 6 SPI interfaces. There is also a programmable audio host clocks that can generate fractional clock frequencies and can be synchronized with the USB clock. There's a built-in 4-word unique device serial identification number. There is also 8 DMA channels with up to 64 kbyte transfers. There's up to 4 CAN bus interface modules, up to 6 UARTs that support both LIN 2.1 and IRDA protocols. There's 6 SPI modules. There's a parallel master port. There's 1 USB compliant on-the-go controller, up to 4 I2C modules, capable of up to 1 megabaud. There's 16 output compare modules, 16 input capture modules. There's a real-time clock and calendar module. So this device is loaded with peripherals. As for programming the NITRO module, the code is developed under MPLAB X IDE, which is currently being displayed here. This is an IDE that Microchip has been developing for probably the last 20 years or so, and it is pretty well state-of-the-art. There's many plugins and tools that are available for MPLAB X through Microchip, MPLAB X is free of charge and can be downloaded from Microchip's website. You also need to download the 32-bit compiler XC32 from the Microchip website, which is also free of charge unless you decide you want to purchase extra compile optimizations, such as compiling for small code size or compiling for speed. One of the plugins available from Microchip is the Microchip Code Composer Studio, which allows you to set up the I/O and the peripherals that are being used for your device. All of the sample code we provide will be based on the Harmony 3 platform under Microchip. Most of them also include an RTOS, which is free of charge, a real-time operating system. Here you can see MCC, the Microchip Code Composer, where you can add peripherals that are supplied by Microchip, and they include just about every kind of peripheral you could imagine. And they show all. And as I'm working here, you can see that there are 6 UARTs you can choose from. Same with timers. There are a bunch of timers, SPI. All kinds of tools are provided through this workbench. And each one of them, when you click on it, after you've added it, you can go in there and set it all up. Here I have timer 8 set up to cause an interrupt, which is enabled every millisecond. So it acts as a system timer when not using the real-time operating system. And again, all of this is free of charge from Microchip. As for debug, Microchip offers several solutions. MPLAB PickKit 4, which is out of production but available on eBay. MPLAB PickKit 5, which is available from Microchip for $99.95, and a nifty little module called the Snap, which is available through their website for $19.95. In all the projects I do, I will use the Snap module. Due to its lower cost, many more users probably will want to look at that option first. MPLAB PickKit 4 and PickKit 5 offer very, very similar solutions. They're just packaged in a plastic case rather than being just a circuit board. We also supply many tools that allow you to just jump right into using the NITRO module. We have a library which contains code for the USB, some LCD displays, and other devices that allow you just to drop those modules right into the project you're working on and begin using them right away. The framework library is a group of frameworks that allow you just to start without having to create a project from scratch. You can load one of these, and it allows you, it basically brings in the entire framework for that setup. All you need to do is add your code and whatever other devices you prefer and whatever other devices you would like to begin using it. The frameworks begin with our bare bones framework. This is basically just the project setup for the CPU. All the oscillators, everything in the CPU are set up. A clock is supplied. What you see here on the screen is the bare bones framework. There's a timer which provides 1 millisecond timer pulses, so you can set timers with 1 millisecond accuracy. The core, which is loaded, which contains one application in the program, and we give instructions on how to add others. It's only a couple clicks of a mouse and you can add more applications. The next framework up is framework RTOS. This contains a real-time operating system which is called FreeRTOS. You can get information from Google on FreeRTOS. All the other frameworks are based on FreeRTOS. Bare bones is the only one that does not have the RTOS loaded into it. So framework RTOS is basically the bare bones with the real-time operating system. We have a framework USB, which has the USB framework set up for a CDC port or a COM port. You just plug a computer into the NITRO module right to the PC, and you can access it through terminal or hyperterminal or any other program that you have that talks to a serial port. There are frameworks for some LCD modules. We are constantly adding these frameworks. We'll also be adding motor control frameworks and servo system frameworks. There is a tutorial directory which contains video tutorials on each one of the frameworks, how to use it, how to install it, and how to add to it or create sample projects based on those frameworks. And we are constantly adding to that also. The My Projects directory is a place where you can copy the frameworks into, rename them, and begin your own projects based on the framework structure plus the libraries that you load. Here's a breadboard we had built up with 3 LCD displays all tied to the NITRO module. As you can see, it's mounted in a breakout board. The 3 LCD displays are running on 2 SPI buses. The big display is running on a SPI bus running at 14 megahertz. The 2 smaller LCD displays and the touch panel on the larger display are running from a second SPI interface which runs at about 2 megahertz. This is because the smaller displays couldn't seem to handle the higher frequencies. This breadboard also contains a servo motor, a UART connected to an adapter driver, and a USB port, also all operating at the same time. You'll also notice that the display is using a bitmap graphic, which is on the 4-inch display, which is about 350,000 bytes in size. It is stored in the CPU flash memory along with the program. So that shows that the NITRO does contain an awful lot of memory space, and I think for this demo we still only used about 68% of the available flash. For more information on any of the debuggers or tools from Microchip, go to www.microchip.com. In the Tools tab, you can find MPLAB X, where there will be instructions for downloading MPLAB X, XC32, and if you search in their search bar, you should be able to find information on the PicKit 5 or the Snap module or the other debuggers that Microchip offers for that processor. For more information on the NITRO module, visit www.saturnpcb.com. You can get information on the NITRO module. If you have an existing product based on the Nano, and if you would like information on upgrading to a NITRO, please send your request to sales@saturnpcb.com. If you have any other questions, you can also email sales@saturnpcb.com. Saturn PCB also offers PC board layout and design work for designing new products based on the NITRO module or the NITRO platform. Or if you just need consulting services for firmware development or help converting an existing Nano project over to the NITRO, those questions can also be answered. Thank you for watching this video. We hope to hear from you soon.